In this section, we'll implement our Fullstack search engine, and we'll do this with PSQL's built-in TS functionality, TS meaning text search. And we'll be making use of a special data type with PSQL, and this data type is called TS vector. And basically what this is a list of lexemes. And lexemes is a list of words that allow you to merge different variants of the same word, such as past tense or the plural form of the word. And as an example, dogs will come up in a search for dog. And this is all default functionality. We don't have to manually set up anything. And then the next PSQL data type we'll need is TS query. And this is basically what allows us to search and compare lexemes. So dog will be a TS query that will be compared with the TS vector. And if there's a match, a row is returned. And TS is a much more effective solution than the like operator, which you might see in older search engines with SQL. And the like operator does something similar to TS, but it does not handle natural language processing. So to get a result of dogs from a search of dog, you would have to set that up manually with like. So TS is obviously a better solution for handling all search. So we'll implement our search engine in our main forum. So let's go in our post.js file and begin setting it up. So the first thing we'll need is a text field where the user can enter in text. And we'll do this right under the sign up to add post and add post buttons. So let's set up our text field. We'll set an ID of search and a label of search, and we'll also pass in a onChange attribute that we'll set up. And we also want to animate our search results. So let's go to our local state and create two new properties. Let's create post search and set it to an empty array, and then post search motion and also an empty array. So post search will be an array of all the search results we get back, and then post search motion will animate these search results. So let's create our first function to handle searching. So let's create a function called add search post to state. And this is the function that will add our search results from our Express backend to our local state. And we'll first set this.set state post to an empty array. And this is because on each search, we want the array to be completely empty. We don't want to stack multiple search results together. And then our second one will set the posts. And again, we're doing the spread operator to flatten the array. And next, we'll also call this.animate search posts, which will be very similar to how we animate posts in our regular forum. And here's a good place to show you how TS vectorization works. So basically, when user submits a post, the title of the post, the body of the post, and the author of the post are all data that's contained in this post. And then to vectorize it, we actually combine all of these separate pieces of data into one TS vector. So this entire TS vector is an array that includes the title of the post, the body of the post, and the author of the post in one array. And each word is one element in the array. And vectorization also makes sure there's no duplicates, and it takes out arbitrary filler words like the and a. So that way you get more meaningful search results. So just typing in the will probably not yield anything because it's just a filler word that's taken out automatically. And now we can set up the function to animate the search posts. So we'll set this up in the same exact way we did for the regular post. So we can just copy and paste the code from our regular animate post function, and then we can modify it. So let's change post motion to post search motion, and then post slice to post search, and then this.state.post motion to post search motion. So let's now create a Redux store that we'll use with this Fullstack search engine. And as always, let's begin in our action types and then create two new action types, search post success and search post failure. And now we can just set up our two action creators to work with this action. So let's first start off with fetch search post. So it will just be action.actiontypes.search post success. And remember the payload of posts as well. And then we can do the same with the remove search posts. And then the most logical place to use these actions would be our post reducer. So let's set them up here. And then let's also create a search post property to use with these actions as well. And then back in our post.js file, we can set up our map state to props and map dispatch to props functions. So we'll do search posts and then set it to state.postReducer.searchPost. And then we want our post success, the action that actually saves the post to our Redux store. So it'll just be post success, then pass in post as a parameter, and then we just do fetch search posts. And now for our handle search function, and this will be the main function that will allow us to use search on our client side. So we'll first have to pass in the event keyword, since again we're going to be using this in the on change of our text field. So what we're going to need is the search query, and this is going to be event.target.value. And again, we do this because it's just a text field, it's not a form. So we don't need to do event.target.search.value. And then we do our axios.getRequest, so it'll be API/get/search post. And then for the parameters, it will just be the search query. And this is all something we've seen many times before. We then use a .then statement, and then we do response. And then we do this.props.postSuccess, our action that we just set up. And then we're going to pass in rest.data, which is going to be our post. We then do another .then statement. And since our last one just saved the post to the Redux store, we can now access it from a Redux store. So it'll be this.add search post to state, which is our local function that saves it to our local React state from our Redux state. And then we just pass in this.props.search post. And again, this.props.search post is coming from our Redux store. And then we just do our error handling on the next line. And now we can simply pass a reference to this handle search function to our onChange event. Remember, we're not calling this function, we're just passing a reference to it. And also notice we don't have a submit button here. This is because we're going to call this function on every keystroke. So what this is going to do is allow instantaneous search results. And we're, again, since this is React in a single page app, we don't want to do submit and then reload the page with search results. We can do it completely dynamically. The user will just enter in key phrases and then have the search results automatically appear if there's a match. They don't have to submit and wait. And again, this makes the forum look very modern and high tech, and it's definitely the way to go. And then we also want to render our post, so we'll do this in a ternary expression. And we'll just do this.state.postSearch. So if the posts are in our local state, then we do the map function on our search motion, and then we pass in each post to the render post functional component. Remember, the render post functional component is the exact same functional component we use to render the regular post in our forum. So we can use the same one here as well. And again, this will give us more consistency and a better overall look in our app. And then for the else statement, we can just do null. And that's really it for the client side. We can now go to the server side and set this up as well. So to use our search vector, we'll actually need to create a new column in our post table. So just create a column called search vector of type tsVector. And as we know, just typing it in here in the SQL schema file does not do anything. So let's open up our shell and then type in the command. To add a column to a table, you do alter table post, add column search vector ts vector. And this essentially just adds a column to our already existing table. And this is really it for the SQL. We don't really have to do anything else. We can now go in our routes and set up the query to work with this TS vector. So we'll first have to modify our post request for saving posts to the database. So we'll have to modify it to basically add TS vectors when the post is being submitted. So let's just copy the post request and then comment out the old one while we set up the new one. So as mentioned, we're going to turn both the body, the title, and the author of the post into TS vectors. So let's create a separate variable for each of them, and let's also pass them into the string function. And then we can combine these three vectors in a search vector variable. And finally, we'll just add this search vector variable to our values array. And then now let's add this to our SQL query. So insert into post, and then let's add search vector as the third argument, since that's what it is in the variables array. And then in our values, we actually do two TS vector on the search vector, and this converts our input to a TS vector where it is saved in the PSQL database. And I'll show you exactly how this works when we submit our post. But for now, just know that our array is now being converted into a TS vector with this PSQL given function. And next we have our get request to get the post from our database. So we'll do router.get API get and search post. And then we'll do a search query of string and rec.query.search query. And this is going to be the same search query that's coming from our text field in the post.js component. And again, remember, this is called every time a user enters a key in the text field. And then we'll do pull.query and then select all from post, so where search vector @ means equals to TS query and then $1. So to TS query turns our search query into a TS query, which allows PSQL to compare them together. So to put it another way, so select all from post. So post table, select all from there where search vector, which is a column name in our post table. So search vector is one column. @ is a match. So where search vector matches to TS query $1. Remember, TS query is a data type that allows us to match TS vectors. And we saw that in the first slide at the beginning. So to TS query turns our search vector $1 that we're getting from our front end to a TS query. And search vector is a TS vector. So TS vector compared to a TS query. And this is what makes search possible. Comparing a vector, TS vector, to a TS query. And then what's returned is everything that matches. And remember, dogs will match a search query of dog. And this is all the code that's needed to make that happen. And before testing our app, let me just fix one small typo. Post here in the add search post to state should be post search. And this is really it. This is all we need to start testing our app. So let's save and go to our browser. So we first have to log in to start making posts. So let's do that now. And then let's add a post of cats and fishes. And this will allow you to see the search query being able to get plural forms of the words that I was speaking of earlier. So let's go to our search bar and enter in cats. And as expected, we do see our search query. And again, we just got returned 2 because cat and cats are both matching. So it accidentally returned it twice because we did it so fast. But if we take the S off cats, we do see cat is still turning up a search results for cats. And this will work for fishes as well. So let's type in fish. And again, remember, our body of the post is available as a search query. And even though it's fishes with a ES, the PSQL dictionary still knows that this is still the plural form of fish. So our search query is still returned. So let's test the past and present tense of words. So let's create a post called walking, and the body can be acted. And let's hit submit. And then if we go back to our search bar and enter in walking does appear as a matching search. So again, the present tense is working. Awesome. And if we enter in act, and again, acted matches act. So our post is returned. So awesome. So this is basically how the present and past tense of words is still shown up in the search query. And then I'll now show you how this looks like in our PSQL database. So let's open up our shell and then type in select all from posts. So here are the 2 posts we just submitted. So we have cat and then :1, fish :2, and then test91 :3, which is the author of the post. And this is essentially how it works. Cat is a string that's being converted to the first lexeme. Fish is the second lexeme. And then test91 is our third lexeme. And that's essentially how it's stored in our PSQL database. And again, notice it's not cats and it's not fishes. Fishes and cats were our original submission to our PSQL database, but since it was a TS vector, it's converted to its base root form, which is what allows it to be compared with other variations of the word cat. And if there's a match, then it's returned. And again, this is the same thing for our second post. Acting and walked was what we submitted, but we see here it's act and walk. Again, this is because, again, even though we submitted the past tense, the TS vector is going to be the root word. And this root word is what allows PSQL to compare different variations of it. And this is essentially how text searching works. And then now I'll just quickly show you that you can also search for the username of the person who submitted the post as well. So if we enter in test91, we see that all the posts that this user submitted are rendered here. So we can also search for posts by the username as well.